Hello guys, in this video I'm going to show you how to solve k-closed numbers. So given a sorted number array and two integers k and x, by k-closed numbers to x in the array, return numbers return numbers in the sorted order. X is not necessarily present in the array. So for example, with this given input that has 5 numbers, k3 and x7. By the way, this array is sorted in ascending order. K3 and x7 means we need to find 3 number that is closest to 7. Close it here means close in terms of the difference, right? So what are the 3 number that has the smallest difference compared to 7? So obviously it's 6, 7, and 8. The difference between 7 and 7 here is 0. The difference between 6 and 8, 6 or 8 compared to 7 is 1, right? So the output we extract here is 6, 7, and 8, right? So for this kind of problem where you need to find top, right? Actually, here's a top k numbers, right? Always think of using a heap, right? So let's see how we're gonna use a heap here, right? We need, because here is closed, right? What kind of heap we need here? Do we need a min heap or max heap? Because here we need the closest numbers, so it means we need the number with the smallest difference, right? So because of that, we have to use max heap, right? Because max heap allows us to have access to the item with the largest value, right? We have instant access to item with the largest value. So it means I can keep our heap size at max of size k plus 1, right? Max heap, let's say, keep it size k plus 1, and because I can have access to the number with the largest difference, right? So I can, when it reaches this size, I can extract the number with the largest difference compared to the x here, right? So at the end, we end up with k small number. So long story short, let's run it manually here. Okay, so the first number to inspect here is 5. Okay, the thing I care here is not the 5 itself, but the difference between 5 and the target number is 7 here. So the difference is 2, but at this point we don't care yet because our heap size is 0, right? We don't care about extracting anything out of the max heap, right? Because its size is 0 now. So let's just add it inside here, 5, right? is 5 at this point that we add 5 in the mark sheet, because it's currently still be the the closest numbers at this point if we do not consider the other numbers. All right, so the next number is 6. The difference here is compared to 7 is 1, right? So I will add 6, and the size now is 2. It haven't reached the k yet, k plus 1 yet, so we just keep adding 6 here. All right, the next number will be 7. The difference between 7 and 7 is 0, right? So it's still 5, but now it reaches side the k, right? But up until now, these are still k closest number to the x, right? Because we only have exactly k numbers in the heap now, right? So we just continue with 8, right? We add 8 here. The difference between 8 and 7 is 1, right? But wait a minute, because the thing we care that is the difference, right? So we need to store the difference along with the value here. So the difference between 5 and 72, 6 and 7 is 1, 7 and 7 is 0, 8 and 7 is 1. All right, so now our heap size reaches k plus 1, which is in this case 4. It 1 larger than the k, right? So it means if I want to find k smallest, k closest numbers to x, I need to extract the extract 1 out of these 4 numbers, right? So what the values that I want here, what the item that I want to extract here, it would be the one that has the largest difference compared to x, right? And because of the characteristic of a max heap, I can instantly get this value, right? In this case, it is this one. So I will take this one now, not because it is first added, but because it has the largest difference compared to x, right? So I will remove this one now. Okay. As you can see, right when it reaches this size of k plus 1, we must rebalance it to k, to size of k. Okay, so we're done with 8. So now come to 9. So 9, the difference with x is 2, right? Okay, so right when is 9 is added to this heap, our heap again reach k plus 1, right? Which is 1 element more than we need, so we need to extract 1 now. In this case, it would be this one. Why is that? Because it has the largest difference compared to 7. So this one now, and at the same time, at this point, we're done with all 5 elements, and we end up with 3 in the heaps, right? And also these are 3 numbers that we need, which is 3 closest number to 7. Okay, but actually there's one thing that we haven't touched yet, which is this is unsorted array. So is there anything that we can improve upon our current implementations, how we can make it more efficient? So because it is sorted, right? It's in ascending order. So it means we can find one number, right? We can find one number very fast using binary search in this case. And questions is what the number that we want here. So the number that we want in this case would be the one that is closest to x in this case, right? So it will be 7, right? So we can find the number that is closest, one number that is closest to 7, closest to x in this case, right? So if I can find this number, what it means here is that k closest numbers in this case will be I can limit the range. I can limit the search space into 3 numbers, right? K is 3, so I find the closest one, and from this one I expand 3 numbers to the left and 3 numbers to the right. That would be the boundary that I will be searching on, right? All right. Okay, so that's the basic idea. So let's get into coding. Right? Okay. The thing that I need here is first find the closest number. Find the closest number to the x here, right? Using binary search. So let's abstract it out into a functions. Let's say binary search. Let's say I need to provide a array and x, right? We want to find closest number compared to x. Okay. The thing that I want to be returned from this binary search is the index of closest num. Okay. So from here I can expand it down. K to the left and k to the right. Let's say it will be low index will be index of closest num minus k, and high index of closest num plus k. So this will be the boundary of k closest numbers, right? Or k closest numbers uh, will be in this range, right? So we can again apply the we can apply finding k closest within this range, right? Okay, find k closest within this range, low index and high index. All right, so I think let's do this one first because this is the main logic of this uh, problem, right? So here is a boundary, so I think I would just uh, I think here we could just add all numbers to the let's say in this case it would be possible that we could use min heap, right, to take advantage of the min heap characteristic, which is allows us to access to uh, the number with smallest difference, right? So we add all number to the min heap, right? So after all numbers is added, we can start uh, taking out k number, right? So the first k number that is brought out is also the k closest number, right? So let's say I will just iterate through each number here. Is low index I using a working pointer I here, less than high index I plus plus. Okay, the current number will be right at index I. So here I need a min heap. So the thing that determines if it is a min heap or max heap is the third argument that we pass in here. It will be a callback, and if it is a min heap, it will be b minus a. But be careful because here what we pass in the min heap is an item in form of an array with the first number is the number itself and the second number is the difference between this number and number x here, right? So the thing that I will compare here is the difference, right? So b at index 1 and a at index 1. So here is a min heap. Okay, so I will just push in the min heap. All right. I push what? I push an array with the first element is a current number and the second is what is a difference, right? So I need the absolute value instead. So it will be absolute of current minus x. So when O is added to the min heap, I will take out k element, right? So the first number, the first item that is out is uh, the closest number, right, to x, and the second will be second closest number. Okay, so let's say how I want to do it here. So as long as k is greater than 0, okay, and each time I will decrement k by 1. I will take one now. I need to store it in uh, output array, for example. So I will take one out and just push it to the output, right? So min heap pop. The thing that is pop out from the min heap is an array, so I care about the number itself. So I will take the one that is at index 0, right? So the number is added to the output, and finally I return the output. Okay. Okay. What is left here is the binary search to find the index of closest number. So be remember that with binary search, the method is sorted array, right? Okay, functions binary search. We are searching for number x inside this sorted array. So for binary search, we need left boundary and right boundary. Left is 0, right is last index. Array.length -1. So we want to continue searching as long as uh, left is less than right, less than equal to right. All right. So I think here we need to because here um, we don't search for exact value, so probably we need to keep track of the currently closest number to exact. Yes, let's say index uh, initially it would be -1, for example, index of uh, let's say index, right? And index is initially -1, and uh, small difference, right, is the small difference of curly small difference, right? So it would be let's say initially it would be mat is infinity, it's very large number, right? Okay, let's say we need the middle index, right? Lat map dot floor lat plus right minus lat divided by 2. Okay, this will give us the middle index. Is the middle index, and I will compare if right dot middle is equal to x. It means the difference is the difference is 0, right? Which is the best difference we can find. So probably we can return right away. We can return 0. No, we return the index, which is in this case the middle. But uh, but if x is greater than array dot middle, then go on here. Else here is x less than number at middle, right? So if x greater than the middle number, it would mean it could be on the right of the it could be on the right of the middle, right? So may want to continue searching on the right here. Uh, if let's say here, if it not equal to x, we probably want to calculate the difference here as well. So I think let's calculate the difference absolute between array at middle and x, right? So the difference here, so I want to know that it is currently this difference is less than the small difference currently. Uh, if it's less than this value, it means that I want to update the index of number with small difference. So index would be the index of middle, right? difference would be the difference itself here. We reassign to difference, right? All right, and mm, if difference here is 0, probably I want to return right away. Return the middle. Else commit is not difference is not 0, so I want to uh, check if this difference is smaller than the small difference right now. If it is, I will reassign the small difference and reassign the index of small difference here. Okay, so after this step, I will continue checking if x is on the right or on the left of the middle number, right? So that I can further limit the search space. So if it x on the right, I will reassign the left to what is that? Because the middle is already checked here, so I want to check for middle plus 1. And if x on the left of the middle, I want to check on the I want to limit the right. Left will be the same, right will be middle minus 1. And finally, when left is greater than right, I mean I've done searching, so I just return index here. Okay, let's run the test here. Just 13 and 8. I think it will work. Oops. All right. We've done something wrong here. Let's see. I know why. It could be the case that when we find a low index and high index, it could be outside the range, right? It could be the low index could be less than 0, right? Or the high index could be greater than array length minus 1. So it means I need to recheck here the low index will be the largest value between 0 and low index. So it means if the low index is less than 0, means this 0 will be greater, then we will reassign to the low index. And the high index here will be the smaller number between array.length minus 1. Here is the largest possible index of, and I will compare with the current high index. So if this current index is greater than this one, it means this one will be smaller and we assign to higher index. Okay, nothing too fancy here. All right, another. Oh. So it seems like the I know why. So because the array now is sorted in the order of difference, right? So the one with smallest difference will be at the head of the output here. But because we want the output to be sorted in the value instead, so I will need to sort it here. All right, so it works. So that is it for this one, and thanks for watching. See you in the next video.